Hey y'all, so today we're going to talk about the steps for naming ionic compounds with a group A metal and a polyatomic ion. And so make sure you have your compound nomenclature packet and make sure you're turned to page 3. And so on page 3 you're going to have compounds that have an A group metal and a polyatomic ion. So there's plenty of practice for you to use. And so before we start with the steps and the practice, I want to make sure we understand what a polyatomic ion is. If you break down the word, it basically gives away what a polyatomic ion is. So poly means many, atomic means atom, and ion means an atom with a charge. And so a polyatomic ion is basically a group of elements with a charge. So we got a group of elements with a charge, and you don't need to memorize that. That is easily accessible on your formula chart. So going through the steps now, they're very simple. There's only 2 steps. And so the first step would be you would name the metal. And then finally, step 2, you would name the polyatomic ion using your, I guess your formula chart, not necessarily the periodic table. So that's my bad. So if you look at your formula chart, you should have something that looks like this. So there's a whole section that says polyatomic ions, and we're only looking at this section right here. We're not looking at the rest of this chart. And so on your formula chart, you have all the polyatomic ions listed that you need to know. And so actually you don't even need to memorize them because you'll always have this chart with you on a quiz, test, or while you practice. But basically it tells you how we name the polyatomic ions and what the formula is for the polyatomic ions. And so what I want to make sure we understand is when we look at something, for instance, like cyanide, cyanide, how we read this is you have Cn and a minus charge. So what this tells me is as a group, so carbon and nitrogen together they have a -1 charge. So together they have a -1 charge. If we look at something like chromate, you have CrO4 2-. And so what this tells me is that 1 chromium and 4 oxygens together have a -2 charge as a whole. So together they make a -2 charge. Same thing with chlorite. You have a ClO2-. So 1 chlorine and 2 oxygens together make a -1 charge. And so these are all your polyatomics. You don't need to memorize them. All you need to be able to do is find them and write them down for me. So if you need to, make sure you pause this video so you can write down the steps on your own worksheet. That way, as you're practicing, if you forget the steps, they're right there on the paper, easy to access. And so what I'm going to do is I'm going to go ahead and start with number 41. And so if you look at 41, we have Al, and so your paper should say L. I circled it, so that's my bad. But it's AlPO4. And so our first step is we're going to name the metal. Al, based on our periodic table, Al is right here. It is aluminum. And so I'm going to go ahead and write down aluminum. And so we're basically halfway there. We're almost done. The rest of them are just nonmetals, and so there's more than 2 elements in our compounds. So whenever there's more, we can assume that whatever's remaining is our polyatomic. So the P, the O, and the 4 are all one ion, one group. And so what we're going to do is we're going to look at our reference chart, or formula chart, under the polyatomic ion section, and we're going to see if we can find PO4 within this list. If you scoot all the way down, you'll notice that right here we got a PO4 right there. So when we name this, we call this a phosphate. So what I'm going to do is I'm going to go ahead and just copy that down. Phosphate. And that's it. All right. So again, all you have to do is you have to name the metal. So if you're not familiar with the symbol, use your periodic table. All right. Oops, that's upside down. Use your periodic table. And then you're going to identify your polyatomic ion using this chart. And then once you identify it, you just write it down. So I'll do one more with y'all, and then we're going to work backwards. And so looking at number 42, we have KNO2. So looking at this compound, I need to first name the metal. So which one's the metal? Our metal is K. And so if we look at our periodic table, we know that K is potassium. So I'm going to go ahead and write down, I'm going to underline it, I'm going to write down potassium. And so we're halfway there again. So what I have left is NO2, so I know I can go ahead and group this up, and this is going to be our polyatomic. So I'm going to go back to my formula chart and look at my polyatomic list, and I'm going to go ahead and look for NO2. So if you look closely here, I'm going to try to scoot this closer. We've got an NO2 and an NO3. So it's very important that you read these carefully, because if you choose the wrong one, the whole thing is wrong. And so we are working with NO2. And so NO2, based off my polyatomic chart, is nitrite. Not nitrate, nitrite. So we're going to go ahead and write down nitrite. So that one letter difference that is that we see between nitrite and nitrate could mean the difference between a right and a wrong answer. So make sure you look at your work carefully. But this would be our final answer for 42, potassium nitrite. And so this one's pretty simple compared to the other ones that we've done. So let's go ahead and work backwards. So let's look at number 51 and 52. So this time what we need to do is we need to write the formula for this. So it's pretty simple as well. All we got to do is write down the symbol, so figure out what the symbol is, find out what the oxidation number is, and then crisscross them if we need to. So for number 51, we've got strontium. In case you don't know, look on your periodic table. Strontium is right here, number 38. And so that's SR. So I'm going to go ahead and write SR right here above it first, because I don't know if I have to crisscross yet. Back to my periodic table. Strontium is in group 2. So group 2, we learned that it has a +2 oxidation number. So I'm going to put SR +2. The next thing we have is carbonate. Carbonate is not something on the periodic table. That is a polyatomic. So we're going to have to use our polyatomic ions list. We're going to find carbonate. Here, it's the third one on there, and it's CO3 with a 2- charge. So we're going to go ahead and write that down. Oops. CO3 and 2- charge. So looking at this, we can see that both of these numbers are the same. And so if the numbers are the same, we do not need to crisscross them. In fact, we can just completely get rid of them. So when I write the formula for strontium carbonate, all I'm going to do is write SR, CO, and 3. And that's it. And so if we look at let's do number 53 actually, because that one we'll have to crisscross and we'll have to pay careful attention to how we write that one. So 53, we have aluminum hydroxide. Aluminum is a metal that we should be familiar with. It's right here, so the symbol is Al. So I'm going to go ahead and write Al. And based off its location on the periodic table, Al is in group 3A, so it's got a +3 charge. And so I'm going to go ahead and write Al +3. And then we have hydroxide. So hydroxide is a polyatomic ion. And so I'm going to have to look at my list. And so hydroxide, if I can find it, is right here. And so that is OH-. So I'm going to go ahead and write that down. H-. And so if there's no number, you can assume it's -1. And I like to write the 1 just so I know if I'm needing to crisscross or whatever. So we got two numbers. Are they the same? They are not. So that means we're going to crisscross them. So this 3 will move to the OH. So OH is 1 unit. So it doesn't move to just the O or just the H. It moves to both. And then the 1 that OH had will move to Al. So when we write the formula for this, again, the metal always goes first. So we're going to write down Al. And the 1 goes with Al, so I'm not going to write the 1 because we don't write 1s. And then next, what we're going to do is we're actually going to draw a parenthesis. And I'll explain why that's important later. We're going to put OH in it, so OH. And we're going to close that parenthesis. And we know that this 3 is now belonging to OH. So we'll put the 3 outside of the OH. And so this would be your final answer for number 53, aluminum hydroxide. Al parentheses OH close parentheses 3. And so the reason why I write it this way is because this 3 that now moves over to the OH, it signifies that we have 3 sets of OH. If you do not use those parentheses and write it like this, what's wrong with it? What's the difference between these two? The key difference is now, this works just like math. When you wrote it this way, you're telling me there are 3 sets of OH. So I've got 3 O's, 3 H's. However, if we wrote it like this, what this signifies is there's only 3 hydrogens, but only 1 oxygen. And so we use the parentheses so that we can signify that the O and the H are one ion, one group, so a polyatomic ion, and we have 3 of them versus just 3 hydrogens or 3 oxygens. So whenever you're doing the crisscross method with polyatomics, it's very useful to use the parentheses so that way your answer is clear and correct. And so this would be your final answer. So again, make sure you're practicing, make sure you're trying this out because practice only makes perfect. And so just make sure you're practicing. And other than that, that's pretty much it for this.